Alright, let's do the question number 71. So we are going to talk about the things called common ion effect, and the solubility of the molecule changes quite drastically if the solution actually contains one of the product ions of the stuff that's dissolving into the water. So let's just try to work on this problem, and then you can actually see how different, what kind of difference we actually get. So MgF2, so let me just try to write out the formula right here. So MgF2, that's solid, right? Is going to dissociate into Mg2 plus 2F, right? Both of these guys are aqueous solution. Then what is the K or the KSP for the product of a reactant, right? So Mg2 plus F squared, right? But if I actually, what is the ratio here? Ratio is 1 to 1 to 2, right? So that means that if I have these things to be x, right, then each one of these guys are 2x, right? And then you have square. So this one right here is actually 4x cubed, just like the previous problem. So let's just try to calculate the concentration of Mg2 plus. So KSP is actually given as 6.4 e to the minus 9, and then that's equal to 4x cubed, right? So what's x here for the concentration of Mg? is equal to this divided by 4. Again, I forgot to use the parenthesis, and then the whole thing by power of 1/3, because I was undoing that cube stuff. So that's Mg concentrations, Mg2 plus, or the solubility, or you can actually consider this as the solubility of the MgF2, right? So that's the solubility, okay? And then for the part B, what if the MgF2 going into the solution which already has the NaF solution, the NaF in there. So for the Mg, the concentration, I'm going to set it as x right here. So let's just say that x to be 0.001, then that one is going to be x right here. And then I have F to be equal to 0.1 plus x, right? Because F can actually come from the previous 0.1 and the Mg2 plus, right? So let's just think about this one. Should I actually put 2x here? Right? Because each time that the Mg dissolve, then I get those guys, right? 2 of those guys, right? And then I have another same stuff, which is well, actually, yeah, why don't I actually do it twice? Because MgF2 means that you have Mg and F, right? So this one right here is the same stuff, 0.1. F could actually come from 0.1 or 2 times this guy, right? And then what is the KSP here, right here? KSP. the KSP is multiplication of all of these guys, right? So KSP is actually equal to this times this times that, right? Good. Now this value right here was a QSP. I should put it as a QSP right here. Okay, and KSP is supposed to be 6.4 e to the negative 9, right? So let's just do the Q divided by K. Q divided by K. What is this thing? It's equal to this divided by that, right? And that value right here is supposed to go to 1 whenever Q is equal to K by changing that one, right? So it's always the same stuff. I want these value. Let me just change the color slightly. I want these guys to be exactly the same number, right? So I'm gonna change this one right here. I'm gonna change this one by changing this. I'm gonna change this one to the value of 1 by changing this. So let's just do that. Solver. I am going to change that one to have a value of 1 by changing this one. Then same stuff here. I'm gonna put this to be 1e negative 20, and then the other one is also 1e negative 20. As long as this number is small enough, then that's works perfectly fine. Look at this. Even though that solution, they say that it couldn't find the solutions, this is the same number, right? So if you keep doing that over and over and over again, it's gonna get there eventually. But this is already close enough for me, so I'm gonna stop this and then just take this value right here. So x is equal to 6.4 times 10 to the negative 7. That's a solubility. And before it was this one, right? This is without f here. So this is without f. And then this one right here, this is with extra f in solution. Then look at the difference between the solubilities here. The without f, it's only like 0.01, right? 0.001, right? So quite a bit of stuff is going to dissolve. But with f floating inside of the solution, you can only dissolve it like 0.000000007, right? So it doesn't dissolve as much as the previous one, and that's a common effect.